Okay, so we were discussing about the information that is related to agriculture and AI, how agriculture and AI goes hand in hand. Now, in this slide, what do you see is about all called as convolution neural networks, or they are also termed to be as CNN. If you remember, in the last lecture, we have discussed something called as image recognition, right? I told you that AI is a field where we have a subfield called as machine learning, and machine is being trained by giving or training the 80% of images or the samples so that machine can predict the information what it has been trained to. Now, convolution neural network are among the most widely used AI models for the image analysis. So this is one what I can say most widely used AI model that we use for image analysis. And we are not talking in anything related to mathematics today about what and how the formulas and the algorithms are working. We are just trying to understand how this work in different stages. So the first stage of convolution is image sliding and a small magnifying glass across an image. Instead of looking into an entire big picture, the AI examines the very tiny regions. It learns and recognizes the edges and the entire, what I can say, picture about it in a more detailed way. For example, the edges, the textures, the spot, the veins, and the other visual features of your, what I can say, farm or a field. Now, next phase comes as pooling, where pooling compresses the information while preserving the most important pattern. Think of it as summarizing an image without losing its essential details. Like, for example, you might be compressing an image. If the image is very large or big, we compress that image, right, with any of the software that is available, but without losing its original form. For example, if you want to concise or, compress the image for maybe 10 documents, you do not want your documents to look blur. You want them to keep it original. That is what it is called as pooling. Then finally, the another layer that is called as softmax layer produces the probabilities. Instead of simply saying that this is the wheat, the AI might give a report that generates that says 98% of wheat, 1% of crop, 1% of soil. So this is what we are calling as a softmax layer. So we said, yes, AI is required for agriculture. That is going to make our things easier. But how things are happening behind the scenes? That's because the one, what I can say, model that we are using in image analysis is convolution neural network that works under three different phases. The first phase is convolution, the second phase is pooling, and the third phase is called as softmax layer. So the CNN
Yes, ma'am.
allows computer to recognize moving on because we have an analysis of image in our brain, and that's how our what I can say convolution neural network mimic the same, and then it helps the computer to recognize the visual pattern. Then this is the slide I have added explicitly over here, because in the last class we were discussing about something related to Indian agriculture, right? So India is actually one of the most largest agriculture producers, but most of the farms are actually owned by a small family owned farmers. So when we are talking about agriculture, when we are talking about farms, we are not talking about very big companies. So very big companies certainly have, a lot of money to invest. But here we are talking about some of the small farmers that they own the family owned business. So this means we cannot simply copy any technology from any country. We need an AI that designs it specifically for Indian farmers. So many of the exciting companies that are already working in space are Croplan In, that uses the artificial intelligence to monitor a crop health and help farmers to make better decision. So this is one of the what I can say Crop In kind of a company that is using artificial intelligence in India. Then next comes as Fussell combines an IoT sensors with AI to recommend the best time to irrigation and fertilization. And Gruda Aerospace builds an agriculture drone that sprays pesticides and monitor crop health. If you see on the slide speaks about the tractor and the farm machinery that is available, the drone-based spraying that is available, precision agriculture, AI startup, and here are few of the future opportunities that we can intervene into. So this is what it is happening already in India to facilitate. Now, many people that assume when every AI application depends on internet, right? And this is not always true. Imagine a tractor moving through a field of 15 miles per hour. If every camera image has to be uploaded in the cloud of processing, every second might have to pass before receiving a response. So by then, the tractor would have already been past the wheat. This is going to delay the process. So in agriculture, latency can make an AI ineffective. Do you get it what I'm trying to say over here? So
Yes, ma'am.
instead of many agricultural performance that inference directly on the machine, this is where we called as edge computing. So edge computing, it is not what we are trying to say from this slide is it is not practically possible to have an internet connection on a very vast or on a very big farm or a field. Now, in order to secure that, we use something called as edge computing, which is a small but powerful computing method on a tractor processes image locally without depending on internet connectivity. Right? So it becomes sometimes impossible to have an internet connection over your land, over your farm, so that it covers the entire images all together at once, or maybe in a fraction of seconds. So for that reason, we are using an edge computing that is a very small and a powerful, what I can say, method where you process your image locally without depending on a internet connectivity. So Edge AI provides several advantages where it works in the remote location with the poor cellular coverage. For internet connection, you require a good cellular coverage. And it also reduces the communication cost. And most importantly, it takes decision in just milliseconds. I'm going to show you how does it looks like. Now, this slide, which you are seeing now, combines everything so far what we have discussed. If you notice over here, there are the cameras that mounted along the spray boom. Do you see the cameras that is being sprayed?
Yes, ma'am.
And
Yes,
as the
ma'am.
tractor move across these cameras continuously, thank you. These cameras continuously capture those images and the AI model analyzes every image in real time. It identifies the soil, crop, and weed separately. When a weed is deducted, the system activates only the nozzle position above the weed. So it is not going to spray the entire farm or a land. It is going to only target the weed. So instead of spraying the entire field, the tractor delivers a tiny amount of exactly where it is needed, the spray where exactly it is needed. So this targeted approach reduces a chemical use and lowered the cost, protected the nearby crops, and minimizes the environmental impact. Right? So from image capturing to spraying, it takes less than 50 seconds. So it has to act very fast. It has to check, see, and then do a spray. That's all happening in 50 seconds. So without edge AI, the what I can say, the part of it called as an edge AI, this level of precision would not be possible. So this is an excellent example of artificial intelligence moving beyond your research laboratories and creating a measurable benefit in the real world. So using an AI, we could able to diagnose the problem, provide the solution within just 50 milliseconds, right? Now, this slide introduced to you about one of the most widely used tool in the precision agriculture that is called as a normalized difference vegetation index. It is also called as NDVI. That is stands for normalized difference vegetation index. Although the equation, what you're seeing over here, I think it's a what we were talking here about in this slide is we are trying to analyze the soil physical and resource boundaries. If you see, it has been classified into two different, classification. The first one is called as physical soil stress, and the second one is a macro resource demand. So when we are talking about a physical soil stress, this is where we are talking about erosion and topsoil stripping. So what's happening over here is we are trying to understand a human induced degradation pattern to build a targeted ecological conservation model. So this is what we are calling it as a soil security, where we are talking about erosion, we are talking about salination, we are talking about structural compaction, and then land allocation efficiency as well as rainfall yield gaps. So these are few of the what I can say challenges that the farmers or the farmland has. So in order to provide the solution, we have a very precision tool or a precision tool in an agriculture called as normalized difference vegetation index. So now, if you see over here, although this equation might look different to us, now what we are trying to see over here is the healthy plant interact with the lightly different than unhealthy plant. If you see very clearly, the slide shows us something called as a device that is measuring a multi-depth of the soil. So this is a particular device that if you see over here, this is a built-in installation, not salt. This is a removable charger battery. This is a mushroom head. This is a detachable antenna, and this is a sensing depth offset. So this device goes inside your soil and try to get the information of the soil on your farmland, whether this soil is moist or it is not moist, whether this soil requires watering or it does not require watering. What is the temperature? What is the humidity? So everything that it is needed to know how healthy your farmland is, this device is going to give us an information about it. Right? And how does it work? It works on the sensors and what we call this as predictive AI model. This is what I was referring to when I was referring to you about the information related to NDVI, where it has a formula that states that NDVI is NIR, that is subtracting red divided by NIR adding red. So what do we mean by this? This is what we called as spectral reflection physics, where NIR over here stands for near infrared. So whatever comes near the infrared rays, if you see over here on the left hand side, you see that the spray is being done. This is the drone, and this is how in the infrared rays your farm looks like. The green color ones are the healthy ones, and the red color ones are the ones where it requires the spray or where it requires an attention that we cannot see it with our human eye, right? Where the healthy plants interact with the light differently than our unhealthy plant. So plant absorbs red light because it has chlorophyll and it uses it during your photosynthesis. And at the same time, the healthy leaves where the strong reflects near the infrared light, where human cannot see near infrared light, but specialized cameras and drones or the satellites can see that. And that's why NDVI compares these two types of light using an equation that is shown on your slide. The higher the NDVI value generally indicates the healthy vegetation, and the value close to zero indicates the bare soil. And the negative value usually represents it requires water. So instead of walking to the thousands of miles or the acres looking around where the stress plants are, where the farmers cannot reach out, we can do this with the help of drones, and that can immediately receive a color-coded health map of the entire field. And by using that color-coded health map, we can understand where does the attention require. Right? It is similar to like kind of an X-ray. If we are seeing an X-ray, we do not understand anything. But at the same time, if the X-ray is seen by a doctor or a professional, then they can understand what's happening inside or behind the scenes.
Ma'am, here I have a question.
Please go ahead.
May I ask?
Yes, please go ahead.
Oh, what happens if an AI system makes an incorrect spraying decision?
Yes, for that reason, we have something called as testing and then moving. Okay, so we will do a testing. Like for example, 80% of our data, we will make our machine to learn. This is how it looks like when you say that it requires an attention, it requires spraying, it requires water, it requires moisture. So this is how the farmland looks like. We will train the machine to understand when it requires spraying, when it requires attention, when it requires a disease monitoring. But again, the AI is not like, 100% where you can rely on, but you can get at least accuracy of 99.9%.
Uh, Here, okay, one another question.
Mhm.
How much training data is required for a reliable AI model?
80%. That's how it goes.
Okay,
80%
thank
of
you.
training. Yeah. Now, when we are moving to our next slide, it says that one of the agriculture biggest challenge is deciding exactly when and how much we need to irrigate. Too little water stress plant or too much water waste resources as it can damage the roots. Now this slides introduces us a mathematical model that estimates a water movement within the soil itself. So we need not to memorize these equations. Do not worry about it. But here I'm just listing that this is the most important idea, is that where AI uses the mathematical model to predict the future water need. So how is that AI working over here behind the scenes? AI is using this mathematical formula which you are seeing in order to understand when does the plant require less water, when does the plant require more water, when does the root is going to damage with the excessive water. So several variable includes irrigation decisions such as rainfall, temperature, right? Then wind, sunlight, crop type, growth stages, soil characteristics. So AI combine all these measurement and recommend the optimal irrigation schedule. So instead of watering the entire field, AI will determine based on this equation that you are seeing that where actually the water is being needed, right? Now, imagine that we are asking a robot drive through a crowded field without damaging a single plant. This is much more difficult than driving a car on a road, right? If we are talking about agriculture robot, we must know that where they are, understanding their surroundings and continuously adjust their improvement. One important technology is called as RTK GPS, right? So what is RT KGPS we are calling here? This is called as real-time kinematic satellites, where it will help us to provide the positioning and the accuracy within just few centimeters. So this robot uses an LIDAR sensors. This is the name of the sensors. Here we are talking about keeping someone in our farm field every time observing. So here we are taking an example of a robot that works on a principle of RTK-GPS integration. RTK stands for real-time kinetic satellites, right? And GPS is a global positioning system, which we all are aware of, that provides an accuracy of few centimeters. And these robots use a sensors where what is that they are doing? The robot, or it is allowing the robot to create a three-dimensional map of the environment. So they creates a three-dimensional map of the environment and they uses an algorithm to estimate its position accurately. Finally, for the safety system ensure the robot stop immediately if a people, animal or an unexpected objects are appeared or they are nearby in the centimeter where we have designed our robot to stop them. And these technology allow autonomous tractors and agriculture robot to operate safely while protecting the crops. Does this make sense?
So basically, we are using GPS role in robot navigation also.
Yes, absolutely. Correct. That's correct. Now let's see how autonomous robot physically remove weed without using any chemical. So if you see over here, this is a traditional farming often requires weed by spraying across the entire field. But today we have an AI powered robot offer a much more precise approach where it uses camera and computer vision, and these robots identify individual weeds while moving through field. And once a weed is detected, the robot removes only the weed. And some system uses a precision layer while other uses a robotic arm or a mechanical tool to cut or pull off the weed from the soil. So either they have being doing a spray thing or they might be using a robot hand in order to remove that particular part from the soil. The biggest advantage over here is precision. So instead of treating the whole field in the same exact way, the robot target only the unwanted plant, and this reduces the chemical use, lower the cost, protect nearby crops, and minimizing the environmental impact. If you see on the screen, you see a robot that is doing a job, right?
Yes, ma'am.
Moving on, we are here going to talk about decarbonizing agriculture with machine
Here
learning.
I have a question.
Mhm. Go ahead.
How does the robot differentiate crops from weeds when they look similar?
We train them. We train them. That's why training is an essential part of an AI. We train the model. We train, test, and then give the what I can say job to analyze. So they will
Okay.
train how does a bad leaf looks like, how does a disease plant look like, how does a weed looks like, how does a crop looks like. So if you see that this is the image of something which is healthy, so you are not going to remove which is healthy. You're going to remove only if you see that the images that are, the leaves are going bad, they are going to smell, the fruits are being ripped or it is being over ripped. Those things you're going to remove.
Okay, ma'am, got it.
Okay.
Ma'am, I have some question.
Okay, please go ahead.
Ma'am, if an autonomous robot operates in the field, won't it damage the field?
Your question is if the autonomous robots are working on the field, will it damage the field? So, if this is your question, then no, we are making these autonomous robots to help the field or the farmers in order to provide ease, right? So we are making them to work for us. We are taking their help in order to improvise. If you remember the very first class, I said that we need to increase the very 50% of the crops and, the lands that we have. So in order to produce a 50% more crops than what we are producing now, we require more land. So that's something which is not possible. So we are using the help of AI in order to use or take a precise decision where a human eye cannot see with their own eyes. I hope that answer your question. Moving on, agriculture and climate change are closely connected. Climate change can affect farming through floods, rising temperature, while agriculture also contributes to greenhouse gas emission through fertilizers and use of the land management. So, what artificial intelligence they help to solve both of these challenges. One example is a carbon, what I can say, capture, where healthy crops absorb carbon dioxide, and AI uses drone and satellites to imaginary or to estimate how these carbons are being stored in the field. That's one thing. That's the solution of the first problem or the challenge, I can say. Then AI also improved the nitrogen management. Instead of applying fertilizers every across the entire field, AI identifies exactly where the nutrients are needed, and this reduces the fertilizer waste, lower the cost, and also decreases the greenhouse gas emission. By combining these two environmental data with AI, the farmers can increase their productivity by protecting their natural resources and supporting a sustainable agriculture. Right? So what was the two challenges? Can anybody tell me? What were the two challenges and how these two challenges are being answered or being, facilitated by AI? See, agriculture and climate goes hand in hand, right? Our agriculture can or the climate change can affect our farming, right? Either it may be in terms of flood, it may be in terms of rising temperature, it may be in terms of heavy rainfall. These could be the conditions of the climate change that will affect directly our agriculture. While the agriculture also requires a greenhouse gas emission through fertilizers to use a land management. So to solve these both challenges, the one example is where the carbon, capture mechanism is being done. The healthy crops absorb carbon dioxide, and AI uses the drones and satellites to estimate how much carbon is being stored in the field. Right? That's the first thing, or the first, what I can say, the advantage. Then the next advantage is AI could also improve the nitrogen management, where instead of applying fertilization to entire field, we will exactly see where the nutrients are being, less, and we can only produce the nutrients or apply those nutrients or send those nutrients to the specific areas where it is needed. And we can by doing this, we are going to protect our natural resources and support a sustainable agriculture. So this is a small activity where now it's your turn that you need to think like an agriculture engineer. So what you are going to see is you are designing a smart greenhouse that can monitor a plant and make a decision automatically. You have to imagine yourself in a way. And then you need to start by deciding which sensors your greenhouse needed, such as soil moisture, temperature, humidity, light, cameras, or CO2 sensors. And then decide how AI should respond. Like, for example, if the soil becomes too dry, it should start irrigation. If the temperature rising is too high, then it should activate the cooling fans and open the ventilation. Does that make sense? Now, finally, think about what action your greenhouse can perform automatically to keep your plants healthy while saving water and energy. Do you get it what I'm trying to ask you, people? Basically, I'm asking you a question. Which sensors do you think is most important for a smart greenhouse and why? Where it should automatically activate something if something goes wrong or something affects in the climate. Anything that is coming to your mind.
Carbon
Carbon sensor, okay. Yes, you can go for carbon sensors. Any other sensors?
Will
temperature
you repeat the
Maintaining the
question?
nitrogen.
Okay, temperature and nitrogen sensors. Yes, that we can do it, definitely.
light sensor
Okay, okay. Light sensors.
and soil moisture sensor.
Okay, absolutely correct. Yes, that is also we can do.
Air
Okay.
humidity.
Yes, that is also we can do. That is something we can provide. Definitely.
Ma'am, I think pH sensor also used because it measures soil or nutrient solution acidity. But we use soil moisture sensor and without using pH sensor. Both works similar.
You said soil sensor and which sensor?
pH sensor
Uh-huh.
because it measures the soil nutrients solution acidity. how much acidic
Mhm.
is soil.
Mhm. Yes, 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 yes. See, these sensors in one or either way provides you the information. But if we are talking about the soil sensor, maybe the soil sensor is going to give us the more accurate value of how the soil temperature has to be. And the pH sensor gives you only the information of the pH value or the acidity or the acids that present in the soil. So both of these two sensors work differently. So when we are talking about pH sensor, that is going to precisely measure the pH of the soil. So moving on, we are going to talk here about the slides that is analyzing the agriculture tech startup and venture capital landscape. If you see over here how the global investor funding AI in an agricultural solution and a critical market has scaling the challenges startup or the what I can say the challenges that are being startup face. So here we are talking here about $250 million venture funding scale, and we are projecting or having an information that there would be an increase or a rise of $518 million, right? Few of the cooperate of AI consideration that is called as Caterpillar, where we have an hardware challenges often leads to industrial asset consolidation. So Caterpillar acquisition of Monarch's patent in April 2026 that demonstrate how enterprise players absorb the startup technology. So this is something and analyzing how the AI scale is being growing. Let's review what we have learned in the last session and this session, and then we will go to our week two. First, we have seen the agriculture faces an enormous global challenges. Second, we have seen the artificial intelligence help farmer to make better decision. And third, we talked about few of the technologies such as drone, satellites, soil sensors, robots, and machine learning that work together to improve the productivity or the challenges that are faced by global, agriculture. Any questions? So in week two, we are here talking about precision agriculture. So can anybody tell me about what is precision, a general meaning of precision?
Means ability to get something similar result
Okay,
repeated.
okay. What do you mean by precise? Precise.
Clear.
Something like summary. In short, there will be idea to
Okay,
find the topic or anything related to that.
okay. So yes, all you said was absolutely correct. But can we say precise like exact to be accurate, right? Precise. That was my precise decision. So here we are talking about how can a smart, um, and, data transforms Indian farming, and what do we mean by precision agriculture, right? Now, what are we referring to when we are talking about precision agriculture over here is, and how the precision agriculture uses the sensors that we talked about, such as IoT devices. IoT devices are Internet of Things, wherein all your sensors comes into picture. Your soil sensor, your humidity sensor, your pH sensors, all these sensors, we classify them as an IoT devices. Weather information and agricultural data sets to help the farmer to make more accurate decision. So your precision agriculture uses sensors, GPS, IoT devices, weather information, and agricultural data set to help farmer understand what decision they have to take based on the entire situation of the field. And how does the entire picture of the field is being presented? It is being presented through n number of sources called as IoT devices, GPS, the weather information, the agricultural data set. So based on all these features that they have, based on that features, they are going to take an accurate decision. This is what we mean by precision agriculture or precise decision, right? Then again, the problem arises precision farming in India is different from a precision farming in any other countries because many Indian farmer works on a small and a fragmented farm and may not be able to purchase the expensive machinery. Do you all agree with this?
Yes, ma'am.
Yes.
Yes. So therefore, our focus today is on affordable and practical technologies, including a dip irrigation, soil sensor, leaf color chart, weather monitoring, and shared sensor network. Right? So our focus is to check an affordable and a practical solution that could provide an ease to the farmers which are working on a very low scale business. Now, traditional versus precise farming. So what's the difference between traditional versus precise farming? The central idea of this precision agriculture is very simple. Three, the right input, right place, right time. These are the three factors or the variables that you need to keep in mind when we are talking about precision agriculture. The right input, the right place, and the right time. So what happens in the traditional farming? The traditional farmings where the farmer may treat the entire field as one uniform area and the farmer may apply the same amount of water, fertilizers and pesticides everywhere. But the problem is that different part of field have a different types of soil, moisture, level, elevation, and nutrient condition. So precision farming are going to measure those differences. It will allow the farmers to apply more resources where they are needed. So for that, first we require a sense. If you see on the screen, we have a sense, that is sensors, drones, satellites, or the weather station that collects the data. Then the second thing is we need to decide. What is that we need to decide? We need to decide what software, what algorithm, what farmer analyzes the information. Then the third thing is something called as act. What does an act do? The farmer is going to adjust the irrigation, fertilizers, planting, or spraying based on the sensors, based on the decision that they have taken. They have to act based on what they have decided. So this loops continues through the growing season, and the most important point is collecting a data is not enough. The data must lead to a farming decision. We are not just collecting a data, we need to provide an information how the decision or the farming decision has to be taken based on what the sensors have been seen, what you have decided, and how you are going to act. Now, sensors, we call them as the eye on the ground. The sensors are sometimes called the eye of the smart farm because they measure the condition the farmers cannot observe accurately by their eyes, by their own eyes. So the first type is called as soil moisture sensor, where it measures the amount of water in the soil. Sensors may be installed in a different depth. Like for example, at the very first point, we have a depth of 2 inches. Then at the second place where we are installing our sensor, it might be at the depth of 4 inches, then might be 6 inches. So based on the different depth, we are going to install the soil moisture sensor, right? Then the second is called as electrochemical sensors that is going to measure the soil properties such as the pH value, the nutrient, including the nitrogen, phosphorus, and potassium. Right? So these two sensors are doing two different jobs. The first one is going to give us an information about the moisture, and the second one is giving us an information about the pH value, the nutrients, nitrogen, phosphorus, or potassium. Then the third type is called as optical or also called as spectral sensor that is going to give us an information of how plant reflects light. One common measure is called as NDVI, which is going to help us estimate how the crop health are being assessed and how much that crop health is being in stress. Then the fourth type of a sensor is called as weather station system, or it is also called as weather station, that is going to measure the information about your climate. When there's a rainfall is going to happen, the humidity, temperature, light, wind speed. right? So at the bottom, where what we can see is called as an IoT data flow, the sensor collects all the data, and then at the gateway, they send this data to LORA, right? Where they get an information about what is happening, and then that information is being stored and processed in the cloud database or a dashboard. Finally, farmer may receive an SMS alert that's saying that, for example, soil moisture is low, irrigation requires in the west field in the evening, like these kind of SMS or the alerts. And how this process is being done? This process is being done on the basis of all these sensors that is going to collect the information, process it through a cellular network or the network that is available, and then the information that is being stored, and then it has been sent to the farmer in the form of SMS alert. Do you all get the weather alert on your phones? Or if there is going to be an alert,
Yes,
Yes,
I do
ma'am.
get.
do you all
Yes,
get those
ma'am.
alerts? How does those work?
Yes, ma'am.
Like an air quality index alert. How does these work? They work based on these sensors. Now, next thing we have something called as local weather and soil health system. Now, national weather forecasts are useful, but they may not represent the exact condition on one farm, right? A local weather station can provide you a Okay, so what I was talking here about weather and soil analytics is national weather forecasts are useful, but they may not represent the exact condition of one farm. So the local weather station can provide the farm level information. For example, high humidity and wet leaves for several hours may increases the risk of fungal diseases. So strong wind may indicate that the pesticide spraying should be delayed because the chemical may drift away from the crop, right? So based on these local weather condition, you can also decide how your farm needed to be, what I can say, managed. And also, a forced warning may trigger a productive irrigation, while a monsoon forecast may tell that the farmer can delay the fertilizer application so on the nutrients should not get washed. Right? For example, you have sprayed all the nutrients, and then in the later evening, there is a heavy rainfall. So it means that all those nutrients have been washed. So soil monitoring provides another layer of information where farmers can monitor the soil moisture at the several depth, soil temperature, nutrients, organic carbon, and soil compaction. Right? For example, below 10%, it is called as a wilting point region. Between 10 and 20%, it indicates the stress. Between 20 and 35%, it presents an optimal range, right? In the particular example. And then above 40%, it may indicate a water logging. That's how a weather and the soil analytics is being done. The next thing we have already seen about something called as GPS and GIS field mapping. The precision agriculture also depends on knowing exactly where the problem is being occurred. A normal phone GPS may have an accuracy of approximately 3 to 5 meters. This may be sufficient for identifying a location of the field, but it is not accurate enough for planting an individual crop row. So for that reason, we require a real-time kinematic global positioning system that can provide an accuracy of less than 2 centimeters. It can support the tractor guidance, seed placement, and laser land leveling. Right? And the GIS system allows us to combine a multiple lab layers. The first layer may show the elevation, then the second layer may show the soil type, whether this soil is clay, sand, or a loam, or the third layer shows its historical yield. So that's how your GPS and GIS fields are being mapped. Then if you see over here, that Indian small holder reality, where now we need to consider the one a reality of Indian agriculture is that many Indian farms or the small fragmentation has been on rain dependent and they are highly sensitive to cost. Therefore, the best precision farming solution may not be an extensive or the expensive autonomous tractors. It may be a low cost sensor that share a weather station, a mobile phone alert, and a drip irrigation system, or even a small physical chart. Are you getting my point? So the farmers, those who cannot spend a huge amount of money buying the tractors, which are AI enabled, having the cameras all over the tractors that is doing the job, they can use a very small sensors, which are very, very, very economic price. They can use those sensors, combine these sensors with the regular, what I can say, the climate data, and then get the alerts, and then they can do their job by at least knowing when they have to irrigate, when they have to plant the seeds, when they have to, water the plants, when they have to spray the nutrients by seeing the weather alert condition, right? Now, there are also major adaptation barriers. And what are those adaptation barriers? The adaptation barriers, farmer may have a limited money. That's what we said. Then second, the fragmented plot may have a large machinery impractical because the field itself is very small. Then the third is also something called as rain-fed farmers, where they may be cautious about experimentations, right? Most of the farmers are from a very traditional farming, so they get very anxious using new technologies. The fourth, access to training at the technology. Even though when you brought a technology, you need to know how to use that technology, right? Then next thing, we have something called as drip irrigation and leaf color chart, right? So what does the drip irrigation and a leaf color chart is doing? This is also a very inexpensive solution for the small farmers. So the first is called as drip irrigation. Instead of flooding the entire field, the drip irrigation sends water directly to the root zone. This can reduce water usage, reducing the pumping cost and improving the crop yield that is specifically used in the area where the water is limited. The second example is called as customized leaf color chart. The customized leaf color chart over here developed for a rice farming, where a farmer compares the color of the rice leaf with the color on the chart, and the leaf green helps estimate whether the plant requires additional nitrogen or no. This is essentially a simple optical sensor that does not require any electricity, network, battery, or computer. That's a very small optical sensor that you can use to see whether the leaf color has been changed or no. The farmer can apply the urea only when the crop indicates the nitrogen is needed, and this can reduce the fertilizer waste and nitrate leaching. Right? So both an advanced GPS tractor and an inexpensive leaf color chart follow the same principle, provided the only correct input that you have to give where and when it is required.
Ma'am, for customized leaf color, there's something that is not understandable. Is that any another language, or it is showing in our system due to the security purpose?
What is that? You're not seeing the slides, you mean?
I'm seeing the slides, but the language for the leaf system, that was something unrelatable to us. Yeah, here, customized leaf color
Oh, okay.
chart.
Okay. Give me
Yeah.
a second. I didn't
What
pay the
is that?
attention. Okay. Give me a second. So what we are seeing over here on this slide, that is slide number 8, is a hands-on activity where we are trying to see how to read the data set. Are you all aware of what data set is? So here, what are we trying to see is we are trying to see how we can read a data set. Okay, so now we are trying to see on this slide a Punjab rice farm data set. Now we are examining a 5-day data set from a hypothetical rice farm in Punjab, which is located in Punjab. The table includes that the rainfall, soil moisture, maximum temperature, plant height, and NDVI, right? Now, if you take a moment to see what does it is looking, or do you observe anything in these, what I can say, the features which I listed just now, the soil moisture, maximum temperature, plant height, and NDVI. Take maybe 30 to 40 seconds and tell me what do you see over here.
Ma'am, maybe I can be wrong, but I want to get the answer that
Mhm.
in day one, there was no rainfall. In day two, there was no rainfall. And in day three, there was no rainfall. In day four, there was a rainfall of 12.4 millimeters. And
Mhm.
similarly, this data tell us how the things are increasing and decreasing day wise.
Yes, absolutely. Yes, you're absolutely correct. So what happens over here, if you see, on day one, the soil moisture is about 28.2%, which is within an optimal range shown in earlier slides, right? In day two, the moisture fall from 28 to 22%, right? While the temperature also increases. On day three, there is no rain. The temperature reaches to 37.5 degrees Celsius, the soil moisture falls 0.8% and the NDVI decreases to 0.58%. So this suggests the crop stress. The plant is still alive, but the heat and water shortage reduces the photosynthetic activity and the leaf health. Then similarly, on day 4, soil moisture reaches to 9.5%. According to our threshold, this is a critical wilting point region. However, the farm receives a 12.4 milliliters of rain, right? So what is happening over here? If we notice that the plant height continuously to increase, plant height does not immediately decrease due to stress, but the NDVI and the psychological activity can respond more quickly. Then likewise, we have day 5 that is giving an information. Now, based on this data set, the irrigation should have been triggered before the soil reaches 10%, probably on day 3. And after the rainfall, and day 4 and day 5 irrigation should be delayed to prevent the water logging. We should also avoid recommending fertilizing immediately before any heavy rain because the nutrients may be lost through the rough of leaching. So what does this data set and how does this data set has been collected? Can anybody answer me?
From analyzing.
No. How do we analyze? Through sensors,
From
right?
sensors.
Yes,
Yes.
absolutely. The sensors what we have installed, based on those sensors, we have selected these features and we got this chart and a table. It is easier now for a farmer, for a person who is managing that land to know what to apply when. Does this make sense?
Yes.
Everybody?
Yes, ma'am. Yes, ma'am.
Okay. So I'm going to quickly give you a kind of a little homework. Just try to see what you can do best. Okay. So for this assignment, you will be designing a low-cost precision agricultural system for a person named called as Ravi Kumar. He has a 3 acres of a rice land and a vegetable farmer in Nasik in Maharashtra. Do you get it? We are here talking about the scenario. The scenario is we are being designing a low-cost precision agricultural system for a Ravi Kumar who is not what I can say having a very huge land, but this person has only 3 acres of a rice and a vegetable farm in Maharashtra. Now, his farm has a clay soil in east, sandy soil in west, and monsoon dependent weather and a budget of 50,000 rupees. So we have all these resources. We know how the land or the soil looks like. We know how much is the money that he can spend, right? So I have divided the task based on your level of understanding. Like, for example, I don't know how many of you are from high school and how many of you are from, undergraduate background and how many of you are from graduate background. So based on whatever you feel easier, right, you can choose. So first, we need to create a budget for the items such as drip irrigation, soil sensors, leaf color chart, and a basic weather monitoring system. Second, we will be estimating expected water saving and yield improvement. Third, we will be explaining how an IoT data flow from the sensors through a gateway works. Fourth, we are going to compare this with the traditional farming and the farming that we are being done with the help of those sensors, right? So if you see closely over here, I have mentioned that for high school students, list 300 words, list any 3 sensors that you should install in the Ravi farm and why. Draw a simple sketch of how this field and where the sensors should place, and explain in your own words how one sensors can save money or how these sensors can save money. Okay, you can choose the difficulty level based on your specialization. If you're a high school student, you can go for this to design, for undergraduate and for master students. But if you all want to start with the very basic thing, you can just give me a simple diagram of how and where the sensors can be installed and how it is going to make a difference. So in the next class, when we are going to see each other again, I will enable the screen sharing where you can share your screen or the homework that we will discuss. Right? Let's summarize this. The 3 major areas or the ideas that we have seen for this particular week 2 session was, the first thing is the sensor that closes the feedbacks between the field condition and the farming decision. Second, we have seen an India's precision agriculture pathway that matches with the very small hold farmers, not a very big farmers that have acres of land. So we have seen some of the practical and inexpensive machineries that we can provide to Indian farmers, those who are coming from a very, what I can say, economic farmlands. Then the third thing, what we have seen is something called as environmental and economical goal can support each other. We can save water, fertilizer, electricity, and pesticides that can reduce farming cost and improve the profit. So this was the slides. Thank you. Before we are going to finish, please do let me know if you have any questions. I am ready to answer your question. And also, please check on the chat. I have given you my office hours scheduling link. I'm going to post it again if you have joined. For this assignment, these slides are available to you people? Are these slides available on the website?
It has not been posted
Ma'am,
yet.
Oh, okay.
No,
yes.
ma'am. Not yet.
Okay, fine. So maybe today later evening or tomorrow, at least if we are not able to post the entire slides, definitely we will post the assignment which I talked about, the home assignment, where you can take a look and understand how things are being done. Okay, fine. Then thank you. Have a great week ahead and see you all next week.
Thank you,
Thank you,
ma'am.
Dr.
Thank you.